Hello, geometry students. Here we are back for more chapter 6. The fun just never ends, guys. So section 6.1 was really all about polygons in general, that some of the interiors, some of the exteriors, regulars. Now we're going to go into the rest of chapter 6 is all about four-sided figures. So the first several will be parallelograms. There's actually going to be a lot of repetition. I think you're going to know what's going on. So just think parallelograms. Notice I've got this parallelogram PQRS up here as an example, and I'm going to use that as an example. I tried to make our lives a little bit easier. So in that first column over here, we're going to write the rule. In this second column, it says if PQRS is a parallelogram, then we know these things. So this is what's true based on that little example at the top. So there is one thing that is not listed in my 4 rules on this table, and that is the definition of a parallelogram. So notice it's already marked. We know what these little extra arrows mean, right? Single arrows, the sides are parallel to each other. Any double arrows, those guys are parallel. So I'm just going to add one little thing. This is the definition. I'm going to say opposite sides are parallel. That's the rule. That's the definition. That's what a parallelogram is. That's why I don't mention it any of these other 4 things. So if we have a parallelogram, then opposite sides are also congruent. Notice we just jotted down the opposite sides are parallel, opposite sides are congruent. So over here in this second column, I'm going to say, well, if that's a parallelogram that I have up there, and I know it is because my opposite sides are parallel, then I can say that side PQ is congruent to SR, and side PS is congruent to QR. Easy peasy, right? That's pretty common sense. We've got that. The next rule. So we're going to know these rules because then I'm going to give you information. I'm going to give you a shape and say, oh, is this parallelogram? Why? And you're going to say, oh, because opposite sides are congruent. It's marked appropriately. So the second rule is the opposite sides are congruent. Oh, sorry, that says opposite angles are congruent. We just talked about opposite sides. The opposite angles are congruent. So in this particular example, that means that angle P has to be congruent to angle R, and angle S has to be congruent to angle Q. I hope you're thinking back to some old alternate interior, consecutive interior, those kinds of things, because that could definitely come in handy in the next box down. So opposite angles are congruent. I could totally see in these first 2 things where things are congruent, I could see equations taking shape. I could say, oh, well, angle P is x plus 2 and angle R is 58. What is x? You'd set those equal because we know that P and R are opposite angles and are congruent. Next thing is taking us back. Consecutive angles of a parallelogram are supplementary. Consecutive angles are supplementary. It really is because the opposite sides are parallel and we've got ourselves a transversal. So I've actually got 4 sets of things that I could write for this, but let's try to make it a little bit simpler than that. We could say, oh, well, angle P plus angle Q have to equal how much for supplementary? 180, right? Or I could say that angle Q plus angle R are equal to 180 degrees. Or I could keep going around. I could say angle P plus angle S. Or I could say, what don't I have yet? S and R? Angle S plus angle R equals 180. Everybody sees the difference between opposite angles and consecutives, right? Consecutives are ones that are next to each other. And last but not least, this one is common sense. If, I'll scooch that up for a second, if a parallelogram has one right angle, then they all are right angles. If a parallelogram has one right angle, then they are all right angles. So I could look at my example up here and say, well, even though it doesn't look like it, if I say that angle R is 90 degrees, that means its opposite angle P has to be 90 degrees. It means its consecutive angles Q and S each have to add up with it to 180 degrees. So angle R plus Q equals 180. If R is 90, Q has to be 90. So I'll say, what do I need to say anything here? Maybe I don't need to say. If 1 equals 90, then all are 90. If one angle equals 90, then all angles equal 90. How about that? That seems the shortest way I can say it. It doesn't matter if it's P, Q, R, S, or whatever letters of the alphabet I give you. So there's our first two rules. So let's look at what kind of problems we might see coming along with this. So if ABCD is a parallelogram, I have to tell you that. Also, I could say, oh, given parallelogram ABCD, that symbol that's usually a lot neater is the parallelogram symbol. Usually looks something, pretend that I'm drawing a really nice parallelogram. It usually looks something like that. Play along with me. Find A and B. So what do you want to find first, A or B? I heard you think A, right? Here's my A information. Is A on a side or an angle? It's on a side. Side AB, we know about parallelograms. Opposite sides are congruent. So that means that AB has to be congruent to CD, which means that 2A has to be equal to 34. Divide by 2, and A is 17. Easy problem, right? B, let's find next, is here in an angle. So angle A, the other piece of information is at angle C. Angle A and C are opposite angles. What do you know about opposite angles in a parallelogram? They are equal to each other. So 8B has to equal 112, which means when I divide, B is going to be something like 14. Is that right? 14, yes. So easy, right? It's just using those rules that we just talked about, opposite angles, opposite sides. Maybe we had consecutive, add them up equal to 180. All right, then we get into diagonals. I need to put this one separate. So I did the same thing. Notice I've got ABCD up here. It's a parallelogram. I just tell you it is. I don't have the markings like I did on the last one. We know it's a parallelogram though because I tell you it's a parallelogram. So the first rule when we're talking about diagonals, notice I've got BD drawn in and AC. They intersect at point P. The diagonals bisect each other. If you draw in both diagonals, they bisect each other. We used the word bisect early in the year, like I think in chapter 1. Bisect means cut in half, right? Two congruent pieces. So that means if these are the diagonals, that means that segment AP has to be congruent to segment PC. And it also means that DP is congruent to PB. I could see an algebra equation taking shape then, right? I could say, oh, AP is, 2x and PC is 57. What is x? So remember, bisect means two congruent segments. It could mean two congruent angles if we were talking about angles, but we're talking about sides. One more thing before I move on to the next box. If I was on a coordinate plane, if I had a parallelogram graphed, and I asked you about the lengths or the position of point P, we would use midpoint. If it's bisecting, it's in the middle. Midpoint is the midpoint formula. That's way back in section 1.3, I think. But we've done midpoint formula, and we're going to need to use it again. Midpoint is add the x's, divide by 2, add the y's, and divide by 2. The other rule when it comes to diagonals, is we go back to congruent triangles. Each diagonal separates a parallelogram into two congruent triangles. So if I just look at segment BD, I could say that triangle above it, ABD, is congruent to the triangle below it, which would be triangle CDB. Got that reflexive side in the middle, all that happening. If I looked at the other diagonal, went this way, I could say that triangle ABC is congruent to the other triangle CDA. So I've got congruent triangles. We're not going to use that quite as much as the other rules, but we can. Also remember we can use alternate interiors here because parallelograms have opposite sides that are parallel, and we've got ourselves alternate interior, like for example, this angle would be congruent to that angle. All right, so let's look at a couple examples, and then I see a graph on the back, so we're surely going to want to get to that. So find the value of each variable. Number 2, I put in a problem that had diagonals in it. So I've got a 3z minus 4 and a z plus 5. I've got little arrows showing that the 3z minus 4 is on this part. The z plus 5 is on this part. Those happen to be diagonals of that parallelogram. I should have said that these are parallelograms. But I know that the diagonals are congruent, so that's going to be as simple as 3z minus 4, or the parts of the diagonals are congruent, I should say that right. 3z minus 4 is equal to a z plus 5. So I'm going to do a couple steps at once. Feel free to split it up. I'm going to minus z from both sides and add 4 to both sides, and I'm going to get a 2z equals 9. And people feel uncomfortable, but z is allowed to be equal to the decimal 4.5. All right. Number 3, I just want to talk about the x's. The y's everybody knows, right? These guys are congruent. Duh, we're done. However, here is my x information. I've got a 4x here, and I've got a 2x minus 6. Are those two angles congruent to each other? The 4x is obtuse, right? The 2x minus 6 is acute. They're not congruent. What are they? They're consecutive angles. They're in a row next to each other, not diagonal, which means these guys are supplementary. So I can do a 4x plus the 2x minus 6 has to add up to 180. Opposite angles are congruent. Consecutive angles are supplementary. So solve this guy, combine like terms. 6x minus 6 equals 180. Add 6 to both sides. So if 6x equals 186, I believe that x is going to be equal to 31. So we're still using algebra in order to solve geometry problems. We use the geometry to set it up, the algebra to solve. Let's see what else we've got. 4 and 5 look good, right? Let's talk about number 5. So it looks like I've got x's, y's, and z's. So let's start with x, just because. Here's a 5x. It's on side QT. What can we use to help us out with side QT? What do you know about opposite sides? They're congruent, right? So 5x has to be equal to 27, which means that x is equal to a 5.4. Help me out, tell me if I'm wrong. Y's. Let's see, where's my y information? Y plus 4, this one's tricky to see. Y plus 4 is here. That y plus 4 is on that diagonal. And the 2y minus 5 is here. So the y plus 4 is on this. The 2y minus 5 is here. It would have been better if, like in that last problem, they would have drawn arrows and showed us. What do you know about the diagonals of a parallelogram? They get bisected, so we know that that 2y minus 5 has got to be equal to the y plus 4. So I'm going to go ahead and subtract y and add 5. So it looks to me like y is equal to 9. And last but not least, let's talk about the z. Here's my z information, 3z. This one is the trick one. This is what I've been waiting for. 3z is in that little pocket right there. This is why I added that extra little thing about the alternate interiors. If you picture these two sides being congruent and you make this your transversal, this angle right here, the 3z, has an alternate interior angle. It's the 33, not the 95. So the 3z has to be equal to 33. Divide by 3, and z is equal to 11. That one had a lot of stuff happening on it, 4 and 5 both. That's why I wanted to talk about them. When I look at number 4, if I were just trying to figure out this 2t right here, this angle, what would you set it equal to? You've got two options down there in the lower right corner. Is the 2t equal to 40 or is the 2t equal to 18? Alternate interior, right? The other side of the transversal. So that would have to be equal to 18. It's the skinnier of the two angles. All right. Last but not least, determine the coordinates of the intersection of the diagonals of parallelogram FGHJ, and it tells you what its vertices are. So let's graph those points. Let's draw in the parallelogram, and then let's draw in the diagonals. So F is at -2, 4. Remember to label your points, please. G is at 3, 5. H is at 2, -3. And J is at -3, -4. I'm going to draw this guy in as best I can. My drawing skills are not always so good. Now I'm going to draw in my diagonals. And then I'm going to label this point right here P, just for the lack of any whatever to call it. M maybe would be a better letter. I'll call it M. Determine the coordinates of the intersection. So I want to know where is M. Now, some of you are going to say, I already know the answer. I've got this. I don't have to do anything. However, you know your math teacher well enough to know that just eyeballing it and writing down answer isn't good enough. I want to see the work. We wrote it down on that little table on the front in order to find M. M is the midpoint. So we're going to find the midpoint of either GJ or FH, or both of them if you want to do a double check and make sure that you get the same thing. So midpoint formula in general is x1 plus x2 over 2, y1 plus y2 over 2. So if we were going to do the midpoint of GJ, we're going to use those for our x's and our y's. If we were going to do FH, we would take the unhighlighted ones. So I'm going to do GJ. You probably already have a guess, I know, but remember, I want to see work. That's how I roll. So GJ, if I add my x's, I'd have 3 plus -3 over 2. Add my y's, I'd have 5 plus -4 over 2. So I believe that midpoint's going to come out to be a 0 over 2 or 0, and a 1 over 2 or a 1/2 or a 0.5. Over 0, 1/2, is that about where your midpoint landed? I can do a check using FH. If I get 0, 1/2, then I know that I did the same thing. So the answer to the question is find the coordinates of the intersection of the diagonals. The coordinate of the intersection of the diagonals is at over 0, up 1/2. Midpoint is your easiest way to do it. Use that wisely. that is it for section 6.2. So about 6 rules for parallelograms as well as using the midpoint formula. Let me know if you've got any questions, and I will see you next time.